Hi, thank you for coming to my talk. I'm sorry I couldn't join you in person. As it turns out, it was probably the right decision because, as I understand, the conference has gone all remote. So I'm joining you from New York. My name is Liz Fong-Jones, and I am a principal developer advocate at Honeycomb.io. So today we're going to be talking about how we can manage complexity in our systems and how we can, as DevOps professionals, make our systems more humane to run. So if you do have questions, as with the other talks during today, the Q&A is on Slido, slide.do, and then you'll put in the passcode Yankee860. And I think it's the same as for the other talks. So if you're already signed in, you can just change the dropdown. So why do I emphasize the value of production excellence and thinking about production? This is for a DevOps audience, not a gigantic surprise, but I think for kind of more generalist audiences and for when you're making the case to other people within your teams, we have to emphasize that, well, we write code, right? Like we're trying to solve problems, we're trying to deliver business value to people. And that means that when we commit the code into trunk, the journey has just begun, right? That our job is not really done until we've actually gotten the code sustainably running in production, not just committed it into trunk where it might deploy days or months or weeks later, and then potentially have to be rolled back. So the challenge that we're facing as people who practice DevOps is that production is becoming increasingly complex. And there are a number of reasons for this. The reason why we have DevOps and how we came to have DevOps was that we recognized that the complexity was better solved by putting people's heads together, by really encouraging collaboration and encouraging people to work together, because otherwise we were not going to be able to meet the challenges of increasing scale and increasing the rate of development. The whole reason why we try to pursue things like microservices is because we want to empower teams to release software separately on their own cadences without strong, hard dependencies upon other teams. Because otherwise, you have a distributed monolith, and that's no fun. But microservices do introduce their own challenges because you no longer can be aware of everything that's happening in your stack, and you can be no longer aware of how things might break people far above you. And furthermore, the more data that we stream through our systems, the greater the workload, the larger the likelihood that at any moment in time, some subset of users is going to be disproportionately impacted, or that we might unfortunately have a negative impact upon someone's life because they can't do something that they crucially rely upon. So we're adding complexity all the time in order to try to solve these challenges. In particular, we've done things like add additional redundancy to systems, add Kubernetes, add sharding, right? And these are powerful techniques for increasing reliability, but they unfortunately have the challenge of creating a lot of operational difficulties. And therefore, it's really, really difficult for us as DevOps professionals in 2020 to understand or tame that complexity and bring it under control so that we as teams can still understand and develop it. So I want to ruminate for a few moments about what the meaning of uptime is, because things used to be a lot simpler. When I was a baby sysadmin, this was in 2004, I was a systems administrator for a game studio based in San Francisco in the United States. And we were a small studio of 12 people, and we had a single product. That single product was a massively multiplayer online game, where massively multiplayer was defined as supporting several thousand people online at one time. And in that environment, we had one game server and one database server. And if the game server was up, the game server was up for everyone. Yes, there were bugs, but from a reliability perspective, up was pretty simple to measure. Could a client connect to the server? So it relied upon, is the server up? Is the database server up? That was it. And yes, I stole this meme from the HSBC ads that you see on airplane boarding gates everywhere. The other way that we can think about things is thinking about when there's actual user pain, thinking about when are people complaining to us. But ideally, we'd like to be slightly more proactive than getting to the point of someone is calling the CEO of your company because they want to cancel your service, right? At that point, it's too late. So, how can we be more proactive while at the same time recognizing that our reality is that we no longer can have a single server that's up? We no longer can have the notion of single host monitoring guaranteeing that things are working correctly. And while we're trying to maintain the baseline reliability of our systems, the other challenge is that we are also expected to improve the reliability of our systems because even if our systems stay frozen in place, our user base is going to grow over time and we're going to need to do more things to scale out. And there are constant demands to add new features as well. So, therefore, it's this constant balance of trying to get everything done in the day, and it can often feel very, very overwhelming. It used to be that heroism could get us through this, that individual principal engineers or lead engineers would work themselves super, super hard and or just think really hard and design a perfect system. But that doesn't really work anymore. We no longer exist in an environment where depending upon single people is a good idea, especially because we have things like someone could get stuck in quarantine halfway across the globe and be unavailable. So we need different strategies. We need to think beyond what we did for the past 5 or 10 or 15 or 20 years that got us to here and think about how do we make things work for the next 15 or 20 years. Now, you may have seen other talks at this conference talking about specific pieces of technology. And I would caution you against thinking that technology is going to magically solve these problems that technology has created. What I've frequently seen when companies try to buy DevOps is that they order the entire alphabet soup without necessarily recognizing what their specific needs are and what's going to actually solve their problems. For instance, if someone adopts continuous integration and continuous delivery in order to ship things faster, that does not necessarily guarantee that the things are going to be correct. A colorful saying is ship shit faster means ship shit faster. There's also the element of thinking about infrastructure as code. So back in the day, I could bring down a single server with one careless command. With infrastructure as code in Terraform, congratulations, I can now crash my entire AWS environment with a single malformed command. Good idea, right? Or what about Kubernetes? Everyone is talking about Kubernetes. It's a hot thing. Should we do it? Well, maybe not. Maybe you don't need a Kubernetes. Maybe you don't need all of that excessive complexity. It depends upon your needs. It depends upon, do you actually have a problem with scaling and orchestrating your containers? Or if you're not even on a containerized environment, then no, you probably don't need a Kubernetes. But I think the largest concern that we have is often that PagerDuty is something that people adopt. The notion of if you feel the pain, you will fix it. I do not think that that's actually true. I do not think that it's actually true that if you provide enough pain to a development team that they're going to magically realize what they need to do to change. Here's what happens when you put a team on call that has never been on call before and has a system that is extremely ill-tuned and offer them very little support. Your alerts go off every single night at 2:30 a.m., 3 a.m., 3:30 a.m. And your engineers get grumpy because while you can wake up at 3:30 a.m. like 1 or 2 nights a week, if you're doing it every single night for a week and doing your day job, you're going to eventually get frustrated enough that you turn off the pagers. But let's suppose that you're motivated enough that you do start looking at that alert at 2:30 a.m. If the first thing that you see is a wall of meaningless dashboards that are not labeled, that are drowning you in all of this complexity and information overload, it's going to be very, very frustrating for you to actually understand what's going on inside of your system. There's both the thing that pays you and a million other things that are also alerting. And you have all of these dashboards with like 10 different pages of dashboards, each of which has 10 different graphs on it. Which line wiggled at the same time as that other line, right? This is what we're using human beings to do, and it is extremely destructive to their mental health. And while you're staring at these dashboards and trying to spend 15 or 20 minutes orienting yourself, your customers are waiting for you to fix the incident, and your incidents are taking longer and longer to fix. So finally, it's 4 a.m. and you pick up the phone and you call your technical lead. Or maybe you are that technical lead who gets woken up at 4 a.m. several times a week and you don't get a break from the pager unlike everyone else because you are the lead of the team. And everyone goes to you for help, whether you're on call officially or not. And that leads to a problem where you cannot take vacations or else the system will go down. And that's no fun. But finally, you fix the problem and it gets to be 8 a.m. and you want to push a longer lasting fix. And then you discover that while the continuous integration works, the continuous delivery does not. That while you're testing each individual piece in isolation, you're not systematically integration testing everything together. That no amount of staging environment testing is actually resulting in having a predictable cadence of release. If you have a robot, if the robot's knee is broken, the robot can't walk, even if each individual bone is fine. So this is a state that we call operational overload, where you have insufficient time to do projects, and you're just constantly juggling all of these fires all the time. And when you do find an hour or two to free up, you don't necessarily have a plan. You don't necessarily know how you're going to allocate your time in order to sustain it, get yourself to a place of being sustainable. So our teams are really, really struggling to hold on in this situation. And I think that it's really unfortunate. Like, I've been on teams like this before, and it's painful. It really sucks. It makes you want to quit your job most days. But I think that there's a better way. So let's focus first on kind of us as human beings, as people. So I'm going to breathe for a second, because every time I tell this story, like every single time, no matter how many times I do it, it reminds me of those bad times as an ops person. And I really need to take a deep breath. So let's all take a deep breath now. That feels so much better, doesn't it? Right? I think the thing that we're missing is that we're missing that people are the ones who operate and develop our systems. And therefore, that we need to refocus on thinking about people first as our approach to DevOps. Our tools are not magical, right? Continuous integration and continuous delivery do not make for a good DevOps practice, do not make for a humane, sustainable team. No tool can help you do something that you don't already know how to do, that you don't already feel inclined organizationally to do. Tools can nudge us, tools can automate workflows, but tools cannot magically solve our culture problems. So instead, we need to think about thinking about how we want to change our cultures, and then after that, we can approach how we want to use tools to facilitate that. So we need to invest in our people, our culture, and our process. That means that we really need to focus on how do we encourage the right practices to happen within our companies. So this is what I call production excellence. It's the art of building sustainable systems that are appropriately reliable, scalable, and don't burn humans out. It's the idea of thinking about not just reliability, but also operability, of making sure that we do not feed human blood to the gears of the computers. So how do we accomplish this? You don't get there through random acts of DevOps. You really have to plan. We really have to map out what are we going to do, why, and how. And we have to measure our signposts along the way. How can I communicate to my stakeholders what they can look for as signs of success? What should they be encouraging? And are we willing to commit to doing the right thing in the long term and not just the short term? As I alluded to with talking about executives, we have to involve everyone. We cannot just accomplish this with the set of DevOps people and the engineers and operators in the room. We also have to involve teams like customer support, sales, finance, and the business overall. And this requires a prerequisite of having an element of psychological safety. We need to make sure that everyone feels safe to ask questions and to contribute what's relevant from their point of view. And we need to not feel paralyzed by fear. So how do we get started with production excellence? Today, I'm going to be telling you the 4 key elements of production excellence. First of all, we need to know when our systems are too broken. Secondly, we need to be able to debug our systems when they are too broken. Third, we need to collaborate across teams in order to accomplish our goals. And then finally, we need to close our feedback loops. We need to make sure that we are addressing risks in our systems and eliminating unnecessary complexity. Of course, there is the notion of essential complexity, of things that are required, parts of our business logic, things that are required absolutely to scale. But not everything needs to be carried along for the ride, so we have technical debt lurking in our system, so we need to address that. So why did I say a moment ago measuring that our systems are too broken? Well, I say that our systems are always failing. So I know that you all are currently in Oslo, where it is probably very gray and overcast, and there's not necessarily grass growing. But here in the United States, have lawns that in many parts of the U.S. are growing year round, and they don't necessarily expect all of the blades of grass to be green, right? You just expect, is my grass roughly green enough? And if it is green enough, then it doesn't matter that one single blade of grass has turned brown. So in our modern environment of microservices, there always will be networking failures. There always will be packets dropped, right? Like, that's fine. The question is it fit for purpose? Does it actually meet our customers' needs? That's what matters, and not micro-focusing on making sure that every part of our system is perfect. So let's measure what too broken is from a business and customer standpoint. This is what I call the service level indicator. It's a concept that's borrowed from site reliability engineering, and it's a mechanism for us to communicate with each other, both among each other as engineering teams who have dependencies upon each other, as well as with our stakeholders in terms of business needs and customers. So they enable us to talk about what reliable enough means. And as the fuel for this, we need to think about measuring our customer experiencing, measuring what are the critical events or critical user journeys that customers are trying to accomplish, and how can we measure them? How can we evaluate all of the context that's involved? Where's the customer coming from? Are they coming from Norway? Are they coming from Denmark? Are they coming from the UK, which is now no longer part of the EU? What build ID are they using? What browser are they using? What was the request ID so I can trace it through the system? These are all super, super important qualities that we need to have in order to understand not just what is failing, but what properties do the failures share in common. And we need to be able to tell which events are good and which events are bad from a customer satisfaction point of view. So one way of doing this is talking to your product manager, or talking to your user experience researchers, or testing on yourself to try to understand what makes for a good or bad user experience. We don't have to go it alone. There's ample research on this subject already. But if you're really not sure, you can just degrade your experience or degrade your customer's experience until you notice that there's a problem. For instance, adding latency to your systems by doing chaos engineering. So discovering that if things take longer than 800 milliseconds, that feels sluggish. Maybe we should make sure that our site always loads faster than 800 milliseconds. So all of this revolves around trying to figure out what's a criterion, what threshold buckets events into good and bad. For instance, maybe it's that the HTTP code is 200 and that we served in less than 100 milliseconds. That might be our criterion for measuring one load of our site. But we also need to think about the denominator. How many total events did we see? The denominator is not 100% of your traffic. The reason is that we need to throw out botnet traffic, right? The 403s that you serve to botnet should not count against your service level objective. Similarly, your internal health checks, while they are a reflection of your own black box monitoring, they don't actually reflect real customer experiences. So we have to focus primarily on thinking about the customer first. And then based off of that, we can compute our total availability, the number of good events as measured by our threshold, divided by the number of eligible events. And that enables us to set a target service level objective. So a service level objective is comprised of the service level indicator, as well as a window and a target percentage. Why is the window critical? You probably can see why the target percentage is critical, but why does the window matter? The answer is a short window is meaningless. If my site were 100% down yesterday, but I came to you and said, I am 99.999% available today, you would scoff at me, right? You wouldn't trust my service. If I had a bad outage 6 months ago, that probably doesn't meaningfully impact your perception of my service today. So pick something between 1 month to a year for your window rather than focusing on a shorter window like a day or a week. So for instance, one service level objective might be that 99.9% of events are good over the past 30 days, where an eligible event is defined as a hit to the home page, and it is defined as good if it was served in less than 100 milliseconds with HTTP code 200. So why did I pick 99.9% or 99.99%? Why did I not pick 100%? The answer is that when you pick a higher reliability target than you and your users absolutely need, you are sacrificing cost and you are sacrificing development velocity. You're paying far more for excessive redundancy that your users will never notice. And you are also sacrificing your development velocity in order to slow down to try to achieve that excessive degree of reliability. We all have applications that, for instance, rely on people's internet connections, especially on mobile devices. And therefore, if your mobile device connects to the internet 99.9% or 99.8% of the time, why does it matter that your service that's on the back end is 99.999% reliable? You won't notice those extra three nines of reliability. So we need to focus instead on barely keeping our users happy, meeting their expectations and keeping their trust without over delivering on reliability and sacrificing on other features that they need. Reliability at its core is a product feature, just like any other product feature. So what can we do that's actionable with our service level objectives? There are two things that we can do. The first thing is that we can use SLOs to drive alerting. We can use SLOs to decide what's an important problem that's customer impacting and what's not. In order to measure this, we need the inverse of the service level objective. We need the error budget, the amount of allowed and availability. If my objective is 99.9% availability over 30 days, then it means that I'm allowed to have 0.1% of my queries over 30 days fail. If I typically serve 1 million requests per month, for instance, then it means that I can have 1,000 requests per month fail. So I can think about how long at the current rate of errors that I'm serving will it be until I exhaust that budget of allowed errors. If it's going to be hours, then I need to wake someone up to stop it before I break the trust of my users. If it's going to be days, it's acceptable for us to wait until the next working day. It's not urgent. And if there is no damage to user trust, then maybe it's not a problem and we shouldn't alert on it at all. We don't need to alert anymore on, oh my goodness, the server is 99% CPU utilization. 99%, this is horrifying. Or the server's disk is 90.01% full. The shock, the horror. So this is a concrete example of an actual outage that we had several months ago. We had a 2% brownout that lasted for 20 minutes at a time for about half, that occurred several times over the course of the day. Traditional monitoring would not have detected this because if you issued a black box probe repeatedly, it would be unlikely that you would be among the 2% of users affected in that 20-minute window. And even if so, it would only be a single blip, not the multiple blips that you typically would require in order to alert someone. Whereas measuring the actual experience of our customers and measuring the extent to which any customer was degraded enabled us to determine that more than 99.99%, that we are not able to achieve our 99.99% service level objective. The second thing that you can do is make data-driven business decisions. You can use your service level objective to answer that tug of war of, do we need more reliability or do we need more product velocity? If you have a service level objective, it enables you to use that error budget, if it's not being utilized on other unpredicted outages, to do experimentation. We can do chaos engineering experiments or feature flag rollouts where we know that the blast radius is contained. We know, for instance, that if we roll out a feature flag to 2% of users, at worst, we will break those 2% of users for 5 minutes before we roll back that feature flag. That seems a lot more acceptable than potentially rolling out something to 100% of users and having it potentially blow up in our faces. Conversely, we may need to invest in more reliability if we've had a number of bad outages. And the service level objective allows you to say, we agreed as a business that this was our target level of reliability that would meet our customers' expectations. If we're falling short of that, that's the first thing that we need to address rather than piling on more features and technical debt. You don't have to be perfect at having SLOs. What you aren't measuring is going to hurt you. If what you're measuring has no correlation to user happiness, you really need to switch to any metric that really will help you measure user happiness. So measure what you can today, even if it is your Amazon load balancer or it's your Google Cloud load balancer logs, and then go from there. Start instrumenting your code even further, but you don't have to be perfect at it. And over time, you need to iterate to meet your users' needs. Maybe their expectations go up or go down with time. Maybe your service level objective is imperfectly measuring things. If you have outages that your service level objective is not detecting, then you need to improve your service level objective. Conversely, if your service level objective says things are wrong for months and no one is complaining, then maybe your service level objective is too aggressive. So service level objectives enable you to prioritize and only alert on what matters, but they're only half of the picture. Why do I say that? Well, SLOs stop you from waking up for spurious reasons, but when you do have an outage, you still need to be able to figure out how we mitigate and how we prevent the outage in the future. So our outages are never exactly identical. We need to begin with curiosity to explore and understand, how is this outage different from anything that's happened before? How can I figure out what's going on? New outages mean new questions, and failure modes can't be predicted in advance. If they could be, well, if you'd be better off buying lottery tickets predicting the numbers than being a software engineer if you had the power to foresee the future. Similarly, if you had the power to foresee the future, you wouldn't write that bug in the first place, right? So by definition, our failures are unexpected. They are unpredictable. And therefore, we have to be able to debug new cases of errors in production, not in staging, not in development, although those are important too, but in production. Your customers will not wait for you to try to take it apart and reproduce it in staging before you fix it in production. That could take days, weeks. Your customers can't afford to wait. So instead, we have to think about, how do we actually empower people to investigate things where we don't have full control over the workload that's being sent. We have to avoid data silos. We have to avoid using disparate tooling. We have to avoid arguing over whose data is correct. Funny story, I know of teams that use a data warehouse for analysis. It takes 2 days to get responses back from the data warehouse. That does not empower you to debug things during an outage. What I found during my time as a site reliability engineer was that I spent most of my time when I was on call and getting paged, forming and testing hypotheses, using that growth mindset to think about, what are the potential things that I might not have thought of? How can I verify them? How can I understand what's happening? So I spent a lot of time trying to figure out, my hypothesis might be, is this component broken for this user? And then being able to actually test and verify that. This requires being able to dive into our data in order to ask new questions. This really, really requires the ability to try to understand, how do we actually use the telemetry and instrumentation in new ways rather than just the same ways that we've aggregated it before. So all of this is to say that our services must be observable, that our systems have to be able to explain themselves to us and answer our questions using the telemetry that they're already exporting, rather than us having to push brand new code in order to understand our services. We have to be able to treat our services as kind of entities that can speak to us, rather than things that we have to push new copies of every time we want to understand them better. In order to do this, we need to be able to examine each of the events that are flowing through our system, and as I said, examine all of those context fields that we need to capture. Can we actually explain the variance? Can we actually understand, is the cluster of failures disproportionately represented among one particular set of users, or among one particular set of build IDs, or some combination of those two? Do we have access to the relevant dimensions, and can our tooling and our mentality about querying it allow us to discover which dimensions are relevant and use that to formulate our response to outages? And better yet, do we really have to be at 3 a.m. debugging things? Why can't we automatically mitigate by rolling back releases or draining from a data center, and debug our problems offline later using the telemetry that was captured during the incident? We shouldn't have to debug things live in production if we can debug things using the telemetry in production that was captured later. But observability is not just for break fix. Observability can benefit us throughout the entire software development lifecycle. From that moment that we write code, wouldn't it be easier if we could debug our test failures or write the instrumentation that we will use in production at the same time that we're writing the code in development rather than bolting it on afterwards? We need to shift adding in telemetry and adding in the capability of observability. We need to shift that left. Similarly, we need to be able to predictably release. You can write the most perfect code in the world, but if you have a build process that is taking hours and hours or even days or weeks, and your changes are batched together with other changes that are likely to fail, that is much harder to practice continuous integration and delivery than if you had visibility into your build pipeline and could understand, why is it getting slow? Why is it getting flaky? How can we make it more reliable? And at the end of the day, if what we build isn't meeting user expectations, then it's not really worthwhile. So can we actually use observability to analyze what users are doing? And finally, we really need to use observability in order to keep control over our systems, to understand where are our risks, where's the complexity, how can we onboard new people, how can new people understand and get visibility into the architecture of the system, thereby managing our technical debt. The other thing is that observability is not just the data. We focus way too much on things like logs, traces, and metrics. Logs, traces, and metrics are a way of serializing the data for human consumption, but they're not actually the whole picture of observability. Observability is a capability of our systems, of our socio-technical systems, comprising both the humans and the computers. Can we as humans write the necessary instrumentation in an ergonomic manner that feels natural to us so that we can produce the relevant data and store it cost efficiently? And then afterwards, do we feel empowered to, both from a social perspective as well as from a technical perspective, query the data to answer the questions that we have? So surface level objectives and observability go together really well because SLOs tell you when things are too broken, but observability helps you debug and fix when that problem occurs. But you also need the element of collaboration. Why is this? As I said at the start, heroism is not sustainable. We all deserve the right to take a vacation. We all deserve the right to change jobs without damaging our teams and without damaging our users. It just isn't sustainable anymore to work for years on end without taking a break, with people bugging us all the time for information that stays locked in our heads. Debugging is not a solo activity. You have collaborations with the people who are currently on call, right? Like, even if your team practices on call where you share the on call rotation, you might write code that goes out and breaks weeks later when someone else is on call. You might have microservice interactions where you have another team service that is also broken at the same time as yours, so you need to collaborate with them. So debugging is really not a solo activity. It involves many, many teams and not just engineering teams. It also involves customer support, your cloud provider. We all care about our customers, so all of us benefit from production excellence and contributing to it. We have to train our teams together. We have to practice chaos engineering. We have to practice game days and disaster drills. That way we understand in a safe environment when nothing is immediately on the line, how things are going to behave when there is an actual outage and incident. Collaboration is deeply, deeply interpersonal. Service ownership does not mean selfishness. It does not mean hoarding my service and saying hands off my service, right? We have to make people feel safe to contribute, to work together, and to not ship our organization charts. We need to lean on our teams. It makes sense to have teams that either practice follow the sun, or even if they don't practice follow the sun, divide up your on-call responsibilities so that you are not on call for 24 hours each day for 7 days in a row. That is not something that is really sustainable to do in the long term, especially with the high paging load. And there are people that have children. There are managers who don't want to get paged during their one-on-ones. There are people who observe religious practices that don't allow them to do on-call during Friday nights, for instance. In the European Union, there's the European Working Time Directive, right? It says that you are not allowed to work people to death, that you have to offer people time off after they work beyond a prescribed number of hours, and that you can't make people work very, very extended shifts, regardless of whether or not you compensate them. If you cannot sleep, you can't be creative. So make sure people are getting the sleep that they need. So share your on-call rotations and divide them up more evenly and cover for each other. And document your practices. Leave yourself cookies, not traps, in the words of my friend Tanya Riley. Write down the right amount. Keep it organized. You don't have to write down everything that becomes out of date quickly. Just write down, what is the service? How is it used? Why is it important? How can I mitigate a failure in the service? How do I roll it back? How do I start debugging? Not every single possible thing that has gone wrong in the past. So fix your hero culture and really share that knowledge out so that you can empower your teams to do more and to do better. So instead of having someone, if someone comes to you and says, I'm sorry, but I'm having trouble understanding this, don't say, I can't believe you didn't know that, right? Like say, I'm sorry the documentation wasn't clear. Let's work together to document this, right? That feels so much better. In this part of the talk, I would normally, with an in-person audience, point to someone that I knew sitting in the front row, but unfortunately, I can't do this here, sorry. And we have to use the same platforms and tools, right? We have to have the same common understanding so that everyone's operating from the same shared data and understanding rather than blaming each other and saying, your service is broken. No, your service is broken. So things like open telemetry, which is a shared standard, can really help you get on the same page with interoperating and instrumentation. And make sure you reward curiosity and teamwork. Practice blameless postmortems. And give people a shout out when they did something that helped you out. My team at work has a channel called #love, where we express gratitude to each other for things that we did. It's amazing. It's a really heartwarming place to be. We also have to learn from the past and reward our future selves by doing those blameless postmortems, but also by doing risk analysis, because our outages do not exactly repeat, but they rhyme, and there are common design patterns that we can use to mitigate our most common sources of outages. So we need to do risk analysis. We need to plan. Why? Well, if you have a bridge that's having cars fall through the roadbed because the roadbed has fallen into disrepair, and there might be an earthquake in 30 years, but it's a while out, so it needs a seismic retrofit, and it needs a shiny new coat of paint, and it needs lights decorating it. Which of these should I prioritize? Which one should I do first? I should fix the fact that cars are falling through the deck of the bridge and falling into the water. So our systems, why do we not treat our systems the same way? Why do we not prioritize what we work on with our systems? You so often see people kind of doing random acts of chrome polishing, doing what seems shiny rather than focusing on the impact first. So we need to quantify our risks by how often they happen and how bad they're going to be. So frequency is something that we don't have much control over, but I think it's important to be aware of, right? If you have a MySQL database that underlies your operations, then you know that MySQL database will fail in some fashion in the next year. You don't know when, you don't know how, but it will fail probably mean time between failures 1 year. So the thing we do have control over is impact. How many people will be impacted when that MySQL database fails? Does it have to be a critical failure, or can we degrade our service in some way so it isn't a critical failure? Can we have it only impact a smaller proportion of users rather than impacting 100% of users? Maybe we can shard things. Or maybe we can have hot standbys so that we fail over more quickly, so that the impact lasts less time. For instance, if we had a hot standby so we could fail over within 5 or 10 seconds rather than having to rebuild the database manually and have it take 30 minutes, well, that shortens the impact of the outage. Or what if we could detect the outage sooner and take action before it impacted 100% of users? These are all things that we do have control over. So multiply these risks out to understand both what's most significant and also what are the changes that would move the needle the most, right? What do I have the most control over that would decrease the greatest amount of risk? And when thinking about this, we need to keep our service level objective in mind. If our service level objective says that we are allowed to have 1,000 bad requests per month, and something is contributing 500 bad requests per month, that is probably a single source of failure that we need to address really, really fast, because that's imperiling our ability to deliver a service level objective, and it doesn't leave enough room for unknown unknowns. Of course, there will be unknown unknowns that you can't predict. That's the nature of the game. But if our known unknowns are taking up so much of our error budget that we have no room left for the unknown unknowns, well, that's kind of the first starting place. And also, critical path latency matters, right? It doesn't make sense to prematurely optimize something that's off of your critical path. If you're trying to achieve 100 millisecond SLO or 100 millisecond service level indicator, then don't fix the thing that's taking 1 millisecond. Take that big thing that's taking 30 milliseconds. That is a single blocking point before you do your fan out. So your service level objective can really help you make the business case to fix them because you've agreed already with your business. This is the level of reliability we're trying to target. This is the level of performance we're trying to target. So if something is imperiling your ability to do that, then we can fix it. And we should devote time to fixing it and actually prioritize completing that work. That doesn't mean write down everything from every single retrospective or postmortem and do all of them. Just find the 2 or 3 most important things and make sure those get done promptly. So don't waste your time doing chrome polishing or side projects. Like experimentation is okay, but like as a comprehensive reliability practice, random acts of reliability do not actually achieve systems reliability and resilience. But here are 2 risks that you may not have thought of. First of all, a lack of observability is systemic risk. If you cannot see into your systems, if you cannot understand your systems, you're wandering around in the dark without a flashlight and without a headlamp. It's going to take you much, much longer to understand and fix every single outage. And while it may not show up as a single item on your chart, if it increases every single other item on your risk chart by 30 minutes or hours or days of duration of impact, that adds up. That really, really adds up. So really prioritize being able to see into your systems. Secondly, a lack of collaboration kills teams and kills products. If you do not feel safe collaborating with other people, if your team points fingers, you're not going to raise an issue and say, I think customers are impacted. You're not going to say, I think it was my change that broke the build or that broke this user. Let's roll it back, right? People feel that they're going to get fired or blamed for pointing out that they were the cause, air quotes, for failure. Remember, outages have triggers and not root causes. Outages have contributing factors. So if we don't emphasize collaboration, our outages are going to take much, much longer to detect and fix. So make sure that you prioritize psychological safety in your organizations. You don't have to be a hero in order to be successful. You just have to practice production excellence. You just have to inspire the right things of culture and practice in your teams. I want to reflect for a moment about the DevOps research metrics by the Accelerate team. So elite teams deploy multiple times per day. They take less than a day from the time that you write the code to the time that it's running in production. It takes them less than an hour to restore service, and less than 15% of their changes fail. And for many teams, it's actually more like 0.1% of changes. So teams are doing this. Teams have gotten there. This is what it looks like, right? Like you have teams now in 2019, their survey indicated that 20% of teams are able to do this. This is amazing, right? Like it used to be fewer than 1%. Now it's 20% of teams. But still, a majority of teams are stuck in the low performance category, where it's taking them months to roll out changes, weeks to fix problems, where 50% of their changes are broken and have to be rolled back and don't get rolled forward for months, right? This is a bad state, and we really need to, as a DevOps community, bring people into the fold and help them get better, to help them progress. What things do we know predict this? Automated build, automated unit tests, automatic deployment to production, and observability. If you can't observe your code, then you have no idea how it's performing in production, whether or not it's broken or whether it's working correctly, and who's impacted. So a dozen engineers are responsible for building Honeycomb. I counted. We have 9 engineers who write code full-time, and then we've got about 5 of us who write code part-time. That's it. And we build systems that we make systems that are humane to run. We make your systems humane to run because our systems ingest your telemetry, let you explore your data, and empower your engineers. And yes, we deploy on Fridays, right? And we don't deploy on weekends because we don't have breaking changes over weekends. So we'll deploy up to Friday, like 3 p.m., 4 p.m. Our criterion is, can you stick around and watch your change? Can you observe your change in production before you go home for the day? And similarly, you can see the gap here, right? Like we didn't deploy over Christmas. We didn't deploy over Christmas. We didn't deploy over a Thanksgiving, right? Like we have a humane practice, but it took work to get there. How did we get there? Well, we started off with making sure that we could deploy things quickly, that we're able to have our builds take less than 10 minutes, that we can push changes out every single hour. The shorter you make your lead time, the more often you're able to deploy. And that means that your changes are isolated from each other and you're only deploying one thing at a time. And that means that you have increased confidence because you're using observability to watch your code both as you're developing it and as it goes out to production. We're able to turn things off with a flag flip or fix forward often rather than having to emergency rollback. Less than 1 in 1,000 changes catastrophically fail for us. We've had, in the past year, over 2,000 deployments, and we've had fewer than 2 catastrophic failures that could not be addressed via flag flip or just degradation and fix forward. And time to restore is really, really low for us because we've really invested in the ability to both observe what's going on and be able to control what's going on. Flag flips take 30 seconds for us. Rolling back to a previous build takes less than 10 minutes. Fixing forward takes only 20 minutes. And this means that our service is able to punch above its weight. We're able to accomplish so much more with 9 engineers than other teams that have hundreds of engineers can do. So high productivity product engineering starts with lead time, deploy frequency, improving change fail rate and time to restore. But all of this is on a bedrock of everyone being invested in observability. So buy the right tools, yes, but make sure that as you're getting that alphabet soup, season it with production excellence. It'll make your teams and your efforts so much better. So production excellence brings your teams closer together when you measure what's broken and measure when things are too broken. How are able to debug your outages with observability, have adequate collaboration between your teams, and have a feedback loop and mechanism of doing risk analysis for addressing your technical debt. Thank you very much. And if you have questions for me, you can go to Slido. It's the Cultivating Production Excellence talk, and the code is at the bottom. And I look forward to seeing your questions. Thank you very much. And if you want my slides, they're at honey.co/Liz or honeycomb.io/Liz. Barcode is in the upper left-hand corner.